Reverse Bessel Polynomials. In this video, we will enter the dataset of the reverse Bessel polynomials using the Taylor Maclaurin series sum. So we'll generate the dataset. I will also generate the trend line equation and the trend line using the chart or the polynomial regression. So we begin with the Taylor Maclaurin series sum of the reverse Bessel polynomial, which is equal to array formula. Now the series sum of A times x, so that's x to the power k, which is from 1 to n. So we are starting with 1, interval of 1. And the coefficient will be this range, coefficient A. So here we have the trend line and the trend line equation, which is also the reverse Bessel polynomial. Then we continue with the values for n and k. In this case, we'll use the values of n from 1 to 6. So data validation and list of items. And our values for n will be from 1 to 6. And our value for k is from 1 to n. So this is sequence of n, comma, 1 column, starting from 1, interval of 1. So in this case, if n equals 1, we have 1, 2, values of k is 1, 2, 3, our value of k is 1, 2, 3. Now we can continue with the coefficients. So our formula. Let's start with the denominator because there are 3 parts in the denominator. We have 2 to the power n minus k. So that's 2 to the power n minus k. N minus k. That's the first part of the denominator. Second part is factorial. That's the factorial of n minus k. So n minus k. And the third part, which is again factorial, times factorial. K minus 1. K minus 1. Now here we have completed the denominator, but we have an error here. If this is 0, if this is empty, this should be 0. To correct that, we use the if function. So if k is empty, 0, otherwise calculate. So k is empty. But if k is empty, then 0, otherwise calculate. So enter. Now we have corrected the error. Now we go on to the last part, which is the numerator, because this is the denominator. We already have completed the denominator. Now we go into the numerator, which is 2n minus k minus 1 factorial. So that is factorial. That's 2n. That's 2 times n minus k minus 1. So that should be okay. So here we have the coefficients, the reverse Bessel polynomial, and the coefficients. So we continue, we start with 1. At n equals 1, the reverse Bessel polynomial y equals 1x. At n equals 2, the reverse Bessel polynomial is x plus x squared. So 1x plus 1x squared. At n equals 3, the reverse Bessel polynomial is 3x plus 3x squared plus x cubed. So 3x plus 3x squared plus x cubed. At n equals 4, the reverse Bessel polynomial is 15x plus 15x squared plus 6x cubed plus x to the fourth. So 15x plus 15x squared plus 6x cubed plus x to the fourth. At n equals 5, that's 105x, 105x squared, 45x cubed, 10x to the fourth, 1x to the fifth. That's 105x, 105x squared, 45x cubed, and 10x to the fourth, and x to the fifth. And at n equals 6, finally. So our values for y is 945x plus 945x squared plus 420x cubed plus 105x to the fourth plus 15x to the fifth plus x to the sixth, and the rest are 0. This completes the use of Taylor Maclaurin series sum to generate the dataset of the reverse Bessel polynomial, and the trend line or the Linus polynomial regression to generate the trend line and the trend line equation of the reverse Bessel